All right, hello everyone again. My name is Daniel Balog from Luciat, and I'm here to give you a brief live demo of the integration of the many services and protocols we've researched in OWS 10 and that all the participants have been included in. We're going to do so by using the Luciat Aviation client. Now, our objective for today is to plan a flight from the Don Lawn Airport to Chicago O'Hare. We will monitor the flight as it travels along its trajectory, and we will send updates to the flight where required. To do this, we will be using two clients. The client on the left is known as the dispatch client. It is responsible for planning flights. It is capable of generating FIXM 2.0 data and send the result to a WFS service using WFS transactions such as insert and update. It can also connect to AXM, FIXM, and WIXM data using WCS or WFS services. The client on the right is known as the in-flight client. It is a more lightweight client. It's currently subscribed to the event service, and it can receive and consume both AXM and FIXM-based events from that service, which it applies to its own data set to have the most up-to-date visualization possible. So the first step, what we're going to do as the dispatcher, using the dispatch client, is open up our AXM data loader panel. We're going to be querying airspace data for a bounding box. To do this in our client, we create a bounding box. I'm going to create a new layer for this, which is called bounding box filter. I'm going to draw a bounding box somewhere around the States. We're going to use this shape as a bounding box filter, and when I click Add, we now actually send a request with the filter containing the bounding box, and we should be receiving this information very soon. So these are hundreds of airspaces you are seeing. We just retrieved them from a WFS service, and as we can see, some of them are closed. So the SAEG 10 styling or based styling that we discussed moments ago is now also active here. Fortunately for us, this does not impede our work. I'm going to delete this bounding box right here. We don't have to leave them. Another thing that we can look at is the destination airport, which was Chicago O'Hare. When I zoom in, I can now see that a runway and a couple of taxiway elements have been closed. Fortunately for us, there are still other runways available, so this should not impede our flight. I'm going to zoom out a bit here, make our airspaces invisible so I have more space to work with. Our next step as a dispatcher is to create a new flight. And to do this, I'm going to create a track layer. And we're going to draw a trajectory all the way from our Don Lawn Airport to our Chicago O'Hare Airport. What we've done now is we've created a trajectory that we're about to insert into a WFS as a FIXM flight object. To do this, we're going to open our flight plan. We're going to select our trajectory that we've just drawn. I'm going to fill in some details. For instance, the goofy, which should be demo run maybe 1. Our departure airport is Don Lawn, and our destination airport is Chicago O'Hare. We're going to choose update route, and we're going to press insert. What happens now is that we send a WFS transactional request to a WFS server containing the FIXM route. We can see on the right that through the event service, our in-flight client has been notified. So this has passed through the WFS service, which has notified the event service, and then the event service has notified us. If we have a look at our incoming event panel, and we analyze the FIXM event, which says we have received a new event, we can indeed see that the ID is demo run 1. Our arrival airport is Chicago O'Hare, and our departure airport is Don Lawn. So we're going to press apply, and when I do this, we actually get a representation of the FIXM route. We're going to customize some other options here because we also want to include some dangerous cargo. So I'm going to check the box for dangerous cargo. And also, we have a simulated flight on our dispatch client, which I'm also going to publish the position of. Now, to do this, I use the WFS update query, so we can update our already existing FIXM flight. I press update. And shortly after, we get a new event. When we have a look at this one, we can see that there are now dangerous goods inside the FIXM object. We have a look at this, we can see that there's a lot of metadata here, for instance, the weight, the volume, etc. When we apply this new FIXM event, we can see that the en route position, which is currently situated in Don Lan Airport yet, is also visible in the in-flight client. Our next step will be to simulate our flight. So in the dispatch client, I'm going to select our flight, and I'm going to start the simulation at a speed of 100. Now, while we're simulating this, I can press the update button, so I can keep sending new update locations. And I do this a couple of times. I'm actually going to speed up the simulation manually a bit. Like that. Maybe one more event here, and maybe one more for good measure. We have now received 5 events. And when we apply these in the order that we received them in, we can actually see the flight being, the flight position, the en route position being changed as time passes. At this point in the scenario, the dispatch client decides that it's a good time to check for weather conditions at the arrival airport, because there are some rumors that there might be some bad weather. So to do this, we are going to draw another bounding box around the area of our arrival airport. We're going to open our Wixom data loader. We're going to select this as a shape, and we're going to press apply. What happens now is we've sent a WCS request with a bounding box filter that's going to return our data. I'm just going to make this have no fill. That's going to return data for this area, so we can have a look at it. What we do in the client is we ping individual locations and see what the results are. So we should be seeing results fairly soon here. There we are. So we have 12 results in Wixom format. When we click on them, we can see that there's a heavy storm in the region. There's 44 knot wind speed, which is storm. There's a wind heavily to the south. There's freezing rain, even in the description. So this is not a good idea. At this point, as a dispatcher, we also decide that we can use the same bounding box filter to query the FIXM data using a WFS request. We're also going to get the density for this. So when I click Add, what happens now is we send a WFS request for the service to make sure that we get all flights in the FIXM format for this bounding box using the bounding box filter provided by the service. And after a brief period of waiting, we should be receiving the FIXM objects. I think there's quite a few, actually. The FIXM data sources are both Eurocontrol and FAA. Oh, there we are. Yeah. So as we can see, there's actually quite a few that intersect in that region. So if we use our density plot, put this a bit higher, we can see that there's actually a fair amount of flights going through this region. Now, for this scenario, we're only going to be focusing on the flight we've just created. So I'm going to make this invisible and the weather data as well. And perhaps remove this as well. So now that the dispatcher has seen the situation, he decides that it's best to notify everyone that the airport is going to be closed. To do this, we open a predefined file, a JMeter file that contains a digital NOTAM to close the entire airport. We press send. And if everything is correct, we've just received a new event that says digital NOTAM, closed airport due to severe weather. We have a look at this. We can also see that it contains a single time slice with the availability set to closed. So when we apply this to the data, our in-flight client is now up to date with the situation, and they know that the airport is closed. Finally, to make sure that the situation is remedied, we choose an alternate airport as an arrival airport. We have our flight plan opened up again, and this time we're going to update our route. We're also going to update our destination airport to Milwaukee. Oh, this should have been, I think, accepted. And we're going to send this update. If we zoom in on the in-flight client and we apply the fixsum event that we just received, we can see that indeed we are now at our new alternate airport. So now when we continue our simulation, I think I clicked this, my apologies for this, and we update our new position a couple of times. Well, finally we land, and we also say that the flight is completed. If we now apply these events, we can also see the flight being simulated to its new destination and finally arriving in Milwaukee Airport.